Apache Spark, a soft introduction. So guys, let's see the agenda. We are going to start with the introduction to big data. Don't worry, I'll just take 2 minutes for big data, not more than that. We'll talk about history of big data engines, comparison between Hadoop and Spark. Then guys, we will talk about limitations of MapReduce. What is the need of Spark? Then guys, we will introduce Apache Spark. We'll talk about its several features, ecosystem components. We'll discuss data flow in great details. Then real life case studies. Then guys, job trends and what is the future. Let's start the session with big data. Guys, big data, the biggest buzzword of the industry, the biggest paradigm shift industry has ever seen. Almost every organization is running behind big data, and it has been very well accepted that without big data, you can't solve all your business problems. So what is big data? The wave everyone is riding, everyone. You take the name of any organization, I would say yes, they are using big data. Nearly all big players, all Fortune 500 companies, and many smaller ones are onboarded. Guys, the most precious element on the planet is oil. Big data is considered as new oil on the planet. Let's see just one basic definition of big data. Gartner defines big data as high volume, high velocity, and high variety of information assets that demand cost-effective solution. Why we need big data? Why business is pretty much interested in big data? For enhanced insights. Today, business is capable, business is getting those insights, those reports which were not available earlier. Industries, or I should say legacy tools, were not able to solve those problems. Today those problems are also solvable. We will talk about all such problems in use case section. Guys, another biggest reason behind big data is decision making. With the help of big data, business is able to take correct decision. Business is able to take right decision at right point of time. Now guys, I am highlighting one V of big data here, that is high velocity. There are several V's, there are almost 8 to 9 V's are there, like volume, variety, veracity, value, volatility, and so on. So guys, apart from velocity, all other V's are very well handled by old big data solutions. Volume, all the big data solutions are providing good storage capacity. Variety, can handle any type of information in that, but velocity is the most challenging dimension of big data. Guys, with the help of our first generation big data solution, Hadoop and native MapReduce, you can do just batch processing. Velocity is not handled by MapReduce. And let me tell you guys, today's at this point of times industry use cases. Industry today is most interested in real-time analytics. What is happening right now? Real-time processing or stream processing. By the way, in use case section, we'll talk about this again. The definition of velocity, if I discuss, the data generation speed as well as consumption speed is velocity. Now, let's talk about history of big data engines. How different big data engines evolved. Or firstly, let's just take the name of big data engines. The very first breakthrough that industry got was Hadoop, which is still the backbone of all the big data solutions. Apart from that, guys, you might have heard about MongoDB, Teradata, Greenplum, Vertica, HPCC, Cassandra, HBase, Storm. Who, by the way, whoever is new for all these terms, please make a note of all these terms. These are popular big data solutions. Not all of them, few of them are pretty popular. So guys, after all these big data solutions, big data engines, still industry is doing lots of research for new big data solutions, because again and again new requirements are coming, new problems are coming which can't be addressed with the existing solutions. So guys, if I highlight just most popular solutions, that is MapReduce. For last almost 7-8 years, MapReduce is pretty much popular and it is solving the batch problem like anything. It is the first entry point for the industry into the big data and was capable to address all the problems that industry that we were facing earlier. These, although not as popular as MapReduce, but yes, it is also providing quite good capability. Storm, Apache Storm, the only solution which was available earlier as well to handle real-time analytics, real-time processing, streaming processing, and the latest component Spark. Guys, these are the 4 components most popular that I have listed, and these are the problems, these are the actual requirement that industry is having. One of the most popular requirement is batch processing. We all are pretty much aware about this. Interactive processing, interactively get the output. Real time streaming, stream analytics, and iterative processing means guys, your program will run again and again over the same data. Like you are doing iteration of like 100 iterations, 500 iterations over the same data. Can anyone tell me example of iterative processing? Correct, Ashish. Machine learning. Take the example, correct Karishma, machine learning. Take the example of classification. Guys, if you want to classify the data, take the example of tweets. If you want to classify the tweets into different segments, you will continuously keep processing that. Why we process that in that many iterations, 100, 500 iterations, for better accuracy. So guys, typical iterative algorithms are in memory. They require in-memory computations. Why? Because again and again writing to disk and reading from disk for iterative is very costly. Now let's see what capabilities MapReduce are having, what problems MapReduce addresses, what problems These addresses, and Storm and Spark. MapReduce, proven solution for batch processing. For all your batch requirement, still industry is using MapReduce. But guys, MapReduce can't handle interactive processing. MapReduce is a high latency system. It can't handle your stream analytics requirement, real-time requirements. MapReduce is not a good fit for iterative processing. What about These? These provides a very nice engine for batch and interactive, but not for real time and not suited for iterative or in memory. What about Storm? Guys, Storm is stream analytics engine which was developed specifically for stream handling, to handle your live stream of data, real stream, and to process that. Storm was developed just for that, not for batch and other requirements. Now if I highlight Spark, which can handle batch processing, although still first choice in the industry for batch is still the MapReduce, but Spark can handle. Spark provides a good interface for interactive processing as well. Now here comes the specialty of Spark is real-time analytics, stream analytics. Spark provides streaming interface. Spark provides iterative. Spark is pretty much, what should I say, one of the best solution for iterative analysis, for in-memory analytics. Guys, earlier in the industry, our requirements was fulfilled by MapReduce plus Storm. Now, instead of MapReduce plus Storm, industry is using MapReduce plus Spark. Although you will surely ask me that when Spark handle batch, why people are still using MapReduce. MapReduce is a proven solution for batch, and still 90% of the guys are using MapReduce for batch processing. Let's proceed ahead. Hadoop versus Spark. Guys, now in the industry there are tons of discussions are going on. Will Spark replace Hadoop? What is the difference between Hadoop and Spark? Can you compare Hadoop and Spark? Guys, I would say this comparison would be an apple versus an orange. You can't compare them. Both systems are totally different. So guys, by the way, next slide only I'll explain it what exactly is the difference. But before that, let's ask a question. Will Spark replace Hadoop or complement existing Hadoop cluster? Although with the tons of features that Spark provide, you might be having an illusion that Spark can replace Hadoop. No, Spark can't replace Hadoop. What is a Spark? Spark is a general purpose cluster computing framework. Guys, this is a computing framework which supports wide variety of use cases. We'll talk about Spark in great detail. Just one liner definition, a distributed computing framework. But there is a big but. Spark says bring your own storage. Guys, make a note. Pretty big statement, pretty big point. Spark says bring your own storage. Spark doesn't provide storage layer. Spark doesn't have any storage layer. Spark is dependent on third-party storage systems for its storage need. To read the data, it needs a third-party system. To write the results back, it needs a third-party system. Now if I ask the question, can Spark replace Hadoop? All of you guys? Yes, no? I think I got all the guys are saying no. Perfect. Guys, Spark can't replace Hadoop. And even Spark complements Hadoop. How? By providing additional capabilities on the top of Hadoop. Let me explain that with the next point. Second statement, what Spark says, bring your own cluster. Guys, Spark doesn't have a specific or doesn't is not deployed on specific cluster. Spark is dependent again on, let's take the real world example. Spark is deployed on Hadoop cluster in real world. Now Spark needs a cluster manager. Spark doesn't have cluster manager. It's having its own local manager. So guys, what Spark can use on the top of Hadoop? Can anyone answer for the cluster manager? Yarn is the best suited for your cluster manager requirement of Spark. Guys, with the introduction of Yarn in Hadoop 2, which supports wide varieties of application in Hadoop 2 itself. What I'm saying, guys, Spark complements Hadoop with additional capabilities. Earlier we just had MapReduce. So guys, you can understand Hadoop is the operating system. Compare one by one comparison. Hadoop, Windows, MapReduce is Notepad, and you got Spark as Microsoft Word. Additional capabilities you got. So guys, you can put Spark as the sibling of MapReduce. Let's proceed ahead. Now let's talk about limitations of MapReduce. Already we had a nice processing framework. Then what was the need of new computation engine? For each and every operation there is a disk seek involved. Disk seeks are very costly, especially guys if we talk in terms of petabytes of data. Reading and writing petabytes of data, you can imagine, is very time consuming, very costly. It's specifically developed to address batch requirements for batch processing. Now guys, one statement, it is not the storage capacity but excess speed which is the bottleneck. Storage capacity tons of systems are providing you, but excess speed. Why excess speed is a little important here? Guys, volumes, petabytes. If to read petabytes of data, if you need say 1 month of time, your system is of no use. Whether you have world's greatest computation system, it's of no use. MapReduce data flow is extremely rigid. Map, then reduce, map, then reduce, and so on. With disk-based approach, each iteration's output is written to disk, making it slow. Guys, first time reading MapReduce, and I'm showing you the example of chaining. First MapReduce is reading the data from disk, writing back to the disk. Although there is one more disk read and write operation is there. Output of map is again written on local disk. 2 times disk read write. MapReduce to again read from disk, write to disk, and so on. For each and every MapReduce job, it will read from disk and write to the disk, which makes the complete flow pretty slow, which degrades the performance like anything. Guys, from the performance perspective, if we compare Spark and MapReduce, for the one iteration, I hope guys now you can understand iterations very well. If your problem is of just one iteration, you can see both of them are comparable. MapReduce is taking 110 seconds and Spark is taking 80 seconds, which is pretty much comparable. I'll not move from MapReduce to Spark for this small difference. But guys, look at it. 30 iterations, if you are having 30 iterations, time required for MapReduce is almost 3500 seconds. Look at the Spark. The time required for Spark is still the same what was needed for one iteration. Every iteration is merely adding 1 second more time. That is 30 iterations. It would be 110 seconds. Compare it. 110 seconds versus 3500 seconds. Huge difference in the performance. Then this is again just for 30 iterations. Practically we need hundreds of iterations. You can imagine, guys, the performance Spark is providing. Let's proceed ahead to Codebase Size. Spark is written with merely 20,000 lines of codes. Now why I'm discussing lines of codes? Guys, more is the lines of code, more are the chances of bug in the system. Apart from that, guys, I'll show you later, the word count example in Spark is merely of 3 lines, which was almost 150 lines of code in Hadoop MapReduce. So guys, Hadoop 1 was developed in 90,000 lines of codes. Hadoop 2 in 220,000 lines of codes. What exactly I'm trying to explain? Guys, Spark is developer friendly. You can develop applications quite easily in Spark. Guys, if we drill down in a little more details here, Spark core, that is the main execution engine of Spark, is developed in 16,000 lines of codes. Operators 2,000 lines, block manager 2,700, accumulator 200, Hadoop IO 400 lines, Mesos 700 lines, standalone, its own standalone backend, which can means if you don't want to run on the top of Hadoop, this standalone backend will come into the picture. That's developed in 1,700 lines of codes. Let's proceed ahead. Now, a question, although I already answered this question, need for Spark. Let's discuss it in a little more details. There is a need in the industry, there is a need for a powerful engine that can process the data in real time, in streaming as well as in batch mode. A system with diverse capabilities. Industry needs an engine that can respond in sub-second range and perform in-memory analytics. So guys, Apache Spark is a powerful open source engine which provides real-time streaming as well as batch processing with very high efficiency, very high speed, ease of use. Just now one example I have given you guys, pretty less lines of codes, and sophisticated analytics. Although Hadoop is effective for storing vast amount of data cheaply, but the computation it enables with MapReduce is highly limited, and it uses a high latency batch model. So guys, if we concentrate here for the Spark, look at the execution model for Spark. First time it will read the data from the disk, whether it is on local disk or HDFS. It will read from the disk. It will process and write to the memory. First iteration. Again, now for second iteration, no need to read from the disk. Directly read from the memory and write to either memory or disk. You have the options available with you. Here I'm showing for the disk, but options are available with you. If you are having less memory, write on disk, else keep writing it in the memory. All the iterations you can write in the memory. When you are ready with the result, write the result in the disk, your output data, right onto the disk. Spark is very well suited for machine learning algorithms. Spark is very well suited for iterative algorithms. Let's proceed ahead. So guys, what exactly is Apache Spark? We already saw lots of capabilities, lots of characteristics of Apache Spark. Let's introduce Apache Spark. Apache Spark was introduced by UC Berkeley in 2009. Guys, Apache Spark is not developed. It was really not developed at Apache. Later, UC Berkeley open sourced it. They donated the complete code of Spark to Apache repositories. It is a general purpose distributed system. Important point guys here is general purpose. At the MapReduce, I would say that is developed specifically for big data. That is developed specifically for huge volumes, specifically for batch processing. But the main design principle of Spark was a general purpose distributed computing system. Guys, why Spark is in the limelight? It provides up to 100 times faster speed than MapReduce. 100 times faster than MapReduce. You can imagine how industry will run behind this particular component. As many of you are aware, MapReduce, when it was compared with legacy systems, it was thousands times faster than older systems. Now you can add two more zeros in that. It's that much fast. It provides a pretty rich APIs in Java, Scala, and Python. Now guys, everybody is having a question. Always there is a marketing term going on, that Spark and Scala. So is it mandatory to learn Scala to learn Spark? Guys, question is again making a little big because Spark itself is developed in Scala. So guys, the answer is no. It's not at all mandatory. Similar APIs are available in Java as well, in Python as well. So if you are an expert of Java, no issues. Proceed ahead with the coding in Java. If you are an expert of Python, no issues. No need to learn Scala. Proceed ahead with Python. But few organizations are making it compulsory that you must code in Scala. They are some design decisions, some high level decisions has been taken by architects that yes, we will develop our project in Scala, or at several places client is taking the decision that you develop my application in Scala. So in those places it's mandatory to have Scala knowledge. It integrates very well with Hadoop and can process existing Hadoop data. No need to extract Hadoop's data. It processes that data very well. And guys, another pretty important feature, another pretty important characteristics of Spark, it also follows data locality. You are having a 1000 node cluster, you are having 100 petabytes of data which is stored distributedly. No issues. Spark will not move your data from here to there. It will process your data distributedly across your 1000 nodes, and that too by following data locality. Let's proceed ahead. Okay, let's talk about Spark features in great details. Force point speed. Always there, if there is a new component, first question from industries about its efficiency. Guys, Spark runs programs up to 100 times faster than MapReduce when you are running the program in memory. But if you are using the disk, on disk, it's 10 times faster. Ease of use. You can write applications quickly in Java, Scala or Python. In all the three languages, rich APIs are available. It's not like that only in Scala all the libraries are available and in Java there is a limitation. No, you can proceed ahead in any of these three languages. Generality. Guys, this is one of the most important feature, although later slide also I will discuss this. You can combine SQL, streaming and complex analytics together in single application. This is one of the most unique feature that is provided by Spark. None of the other system in the world provide this particular capability. You can mix different type of applications, different type of logic in a single application. You are having need of stream processing and parallelly you want to call some old data that is available in your storage, some sort of like Hive that is structured, call SQL. You can combine machine learning also with your streaming and so on. Guys, this was the biggest pain point that industry were facing earlier. I'm sharing this from my personal experience. Our applications were becoming much too complex without this particular feature. We were needing again and again process more iterations, more data. In first iteration, streaming is going on, and then after that we will store that data somewhere to compare it with, say, your SQL. But here no need of that. In a single application, use all the types of engines whatever you need. You by the way guys, you should make a 5-star mark line for this particular feature. As discussed, it integrated very well with Spark or very well with Hadoop. Spark can run on Hadoop 2's Yarn cluster manager and can read any existing Hadoop data. About data operations, guys, we have a new term called RDD here. Resilient distributed data set. You can note down resilient distributed data set. RDD is the basic abstraction in Spark. Like guys, in MapReduce, what I told that if you understand the logic of key value, you can crack any problem. Here I would say if you understand RDDs, you can crack any problem. By the way, there is a dedicated slides for RDD. We'll discuss it there. RDDs support two kinds of operations. Transformation, that is transformation of data from one format to another. Transformations create new data sets from the existing one. And second is action. Guys, action is the actual computation. Action is the actual calculation which returns a value, which returns the result. Let's proceed ahead to RDD. By the way guys, I'll be needing almost 4 more hours to discuss RDD completely, but let's have a basic introduction of RDD. What is resilient distributed data set? It is the basic abstraction in Spark. All your processings will be on the top of RDD. So guys, RDD represents an immutable partition collection of elements. Your collection, RDD is a collection which is immutable. Please make a note. RDD is a collection which is partitioned. Pretty important point. RDD can be operated in parallel. RDDs can be operated in parallel. So guys, basic operations available on RDDs are like map, filter, poses, etc. RDD actions and transformations can be used for complex computation. Let's discuss what is transformation and what is action. Let's discuss even these transformations and actions in more details. So guys, what are the different RDD operations? Programmers can perform three types of operations. Very first, transformations. Create a new data set from existing one. Transform the existing data set into newer format based on requirements. Transformations are lazy in nature. Guys, this is a little important point. Transformations are lazy in nature. What do I mean by that? They are executed only when some action is performed. Like you are performing a transformation, but it won't be executed until unless you perform any action. Apart from that, your data will not come into the memory until unless you apply any action. Examples of transformation: map, filter, distinct, etc. So guys, in almost each and every practical, we will use different operations like transformations or actions. Now, actions. Action is the actual computation. It's the actual calculation which returns to the driver a value or export data to storage system. Action is your submitted computation logic, like count is an action, reduce, collect, take, etc. So guys, firstly you perform basic transformations, then action, and generate the result. And if this is an iterative, again and again doing the multiple transformations and actions. Now another operation is persistence. Why persistence I'm calling as an operation? Guys, for caching data sets in the memory for future operations. One of the most important point behind the popularity of Spark, you can cache your data. Let me highlight it here. You can cache your data in the memory. You can cache your data in the memory for future operations. No need to read again and again from the disk. By the way guys, if you are having limited memory, then we have other options available. Options to store on disk, on RAM, on both together. What do I mean by that? Guys, suppose you are having sufficient memory available, store all the data into the memory. You are having limited memory available, can't store all the data in the memory. What will you do now? I'll store all my critical data in the memory, rest I'll write on the disk. For your specific application, there is no memory available. Use complete disk analysis, write complete outputs on the disk. All the options are available. Let's proceed ahead. Spark programming model. This is a little important slide, guys. Understand this carefully. Programmer, developer, develop the Spark application. He will develop the firstly the driver program. What is the driver program? Can anyone tell me? Driver program is the main unit of your execution, from where your actual execution will start. Driver program create the most important object that's called Spark context. Driver program is your main function, is your start of your execution for the application. Second point here important, Spark context. Spark context represent the connection to the Spark cluster. Guys, you should note down these points. Represents the connection to the Spark cluster. It provides the entry point. It provides the entry point for interacting with the Spark. Spark context, using which we can read the data from data store, using which we can interact with jobs. Now guys, your Spark context will interact with the cluster manager. It will interact with the cluster manager. If you are using it on the top of Hadoop, then it would be your Yarn's cluster manager, that is resource manager, which will schedule your work on the worker node. Worker node, guys, slave nodes. Worker nodes, I'm just parallelly telling you Hadoop terminologies as well. The general technical terminology. Worker node, your slave nodes, where your work will be executed, where your actual work will be done. Guys, here your container will come into the picture, your executor will come into the picture, that will run multiple tasks. It will read the data from underlying data store. If it is on the top of Hadoop, it will read the data from HDFS. If from running on local file system, read from the local FS. So what is the task? Task is a sub job, sub work, part of the work. Required data you can cache into the memory. That would be available for next operations, next iterations. So guys, this is the end-to-end model for your programming in Spark, end-to-end execution model, Spark execution model. Alright guys, let's proceed ahead. Now let's concentrate on the second line of our program, RDD, that's resilient distributed dataset. Few features of RDD we already talked. Guys, using RDD you can read the data from underlying data store. Using RDD you can interact with your running applications as well. So guys, what exactly is RDD? Why I'm highlighting RDD so much? It's an immutable data structure. It's a distributed data structure. Guys, it is because of RDD only Spark can process data distributedly and follow the data locality, because your data structure, your collection RDD itself is distributed. It's having controlled partitioning. Another pretty important feature guys, fault tolerant. RDDs are fault tolerant. At any point of time, if any machine is down, no issues, it will keep all the execution points ready. It keeps all the execution flow in directed acyclic graph. It will reschedule those particular execution point and generate your data. Guys, important point, no need to restart the work from the scratch on any failure in memory. in memory, explicitly in memory. That is, you can specify whether you want to keep your important data into the memory. There are tons of operators available. So guys, you don't need to code much. Use inbuilt operators. That's why you'll see Spark's code is pretty small as compared to Java. It's almost negligible. Let's proceed ahead. Now let's talk about data flow in Spark. Although at basic level we already talked about it. Guys, how your end-to-end data flow happens in Spark application. First point, entry point, start point is your start is input data. Input data will always be stored on underlying data store, that is suppose HDFS. That would be read from HDFS, that is ultimately from the disk when you run your map operation. When you run your map operation. Now guys, the output, that is first RDD. Some part is available in the memory, some part is available in the memory means memory resident. Another part not available in the memory, that is not memory resident, that is spilled to the disk. Due to the limitation of disk, you can do this. Oh sorry, due to the limitation of memory, you can do this. Now guys, your iteration number 1, processing, all the processings are going on output. It is caching your output for second iteration, third iteration, for nth iteration. It is keep caching your output into the memory resident. Your RDD is memory resident. Once all the work is done, once the result is ready, it will write the final output onto underlying store, that is HDFS. That's guys end-to-end data flow in Apache Spark. Let's proceed ahead. Now let's talk about Apache Spark ecosystem. Spark is having lots of members in its ecosystem. The very first component is Spark core. Guys, Spark core is at the heart of Spark. Spark core is having all the important code. It's the component which provide in-memory computation. Spark core is the most important component in the ecosystem. On the top of which we are having Apache Spark SQL, which provides a mechanism for the user to submit SQL queries on the top of SQL. Apart from that, we have Spark Streaming, which enables user to process streams of data, to enables user for stream analytics. We have MLlib, machine learning libraries, quite rich machine learning libraries are available, using which we can perform various operations like classification, clusterizations, and so on. Apart from that guys, we have GraphX library, that is graph computation engine. Guys, the storage model of graph is pretty much different than other storage other components, other data like your structured data or semi-structured data like JSON or Excel or XML or purely unstructured data, paragraphs or your multimedia. The structure of graph is pretty different from them. Graph, it is having connected edges. It requires different level of indexing. So guys, if I give you one example, I'm sure all of you guys are using LinkedIn. So guys, suppose there are 3 users on LinkedIn, A, B and C. A is connected to B and B is connected to C. A and B are first degree connections and A and C are second degree connections. So guys, if I give you an example to find out first degree connection or second degree connection of all the users of LinkedIn, you will be needing almost a month of time after using MapReduce. I'm not talking about legacy systems. Even if you use big data systems, then also it will take months for volumes. Even if you don't use GraphX and use Spark as well, then also it will need months, because guys, the processing model and indexing model of Graph is pretty different. On the other hand, at the volume of LinkedIn as well, if you use GraphX or Neo4j, it will give you results in minutes or hour level. It makes in hours. So always it is recommended that to handle graphs, you should use graph engines. Now guys, look at it. All the components, whatever I have explained you, all these components are just execution engines. All are the computing elements. Storage layer is missing. Where is the storage layer in Spark? Storage layer. There is no storage layer in Spark. Please make a note. There is no storage layer in Spark. Spark is dependent on third-party systems, third-party storage systems for its storage needs, like Hadoop's HDFS, like HBase, like Cassandra, like S3, and so on. Now guys, if we talk about the most popular combination, although it depends on problem to problem, the most popular combination, that is Spark sits on the top of HDFS. Spark use HDFS as the storage layer. As soon as guys I say Spark storage layer is HDFS, you should recall all the characteristics of HDFS that is ultimately be added to the Spark, like distributed storage capacity, reliable storage, fault tolerant, high availability, reliability. All such characteristics are ultimately added to the Spark from the perspective of storage if we use HDFS. So guys, recall our earlier discussion. Can Spark replace Hadoop? Surely not. It even complements Hadoop. Let's talk about ecosystem components in more details. First component, Spark Core, is the execution engine for Spark platform. It's the core execution engine which provides in-memory computation capabilities, which provide high efficiency, which provide pretty high speed, provides a generalized execution model to support wide varieties of applications. Another component, Spark SQL, which enables users to run SQL or HQL on the top of Spark. It is an engine for Hive data that enables unmodified Hive queries. Guys, important point here is unmodified Hive queries. No need to modify your existing queries, and run up to 100 times faster on existing deployments and existing data. All your complex Hive queries, guys, if you recall, if you have worked on Hive, it is converted into multiple MapReduce job. As soon as it is converted into multiple MapReduce jobs, it is costly. On the other hand, with Spark SQL, it is 100 times faster. Now, pretty unique, pretty different, pretty innovative component, that is Spark Streaming, which enables powerful, interactive and analytical applications across streaming data. By the way guys, there is a dedicated slide for streaming. We'll discuss it in great details there. It readily integrates with wide varieties of sources. data sources like Flume, Kafka, Twitter, and so on. MLlib machine learning library is a scalable machine learning library that delivers both efficiency and high quality algorithm. Efficiency, since it sits on the top of Spark. GraphX, a graph computation engine built on top of Spark that enables user to graph data at scale, to compute the graph, to process the graph data at massive scale. So guys, these are the major ecosystem components on top of Spark. Now, if we talk about Spark streaming in great detail, streaming is today's need. Everybody is running today behind the streaming, stream analytics, stream processing, real-time processing, and so on. So guys, how to imagine a stream of data? You can imagine like a water pipe, a, how water flows, how water stream flows. Similarly, your data stream will be flowing in the Spark, or data stream will be flowing via the network. If I talk about Spark streaming, it receives data streams from input sources. Input sources can be any of these sources. There are tons of sources supported like Kafka, Flume, 0MQ, so on, and process them in the cluster. It processes even stream also in the cluster and pushes the data, pushes the output onto the data store, onto the dashboard. Let me explain this particular definition. Let me explain Spark streaming with an animation. Guys, we have Spark streaming. Suppose this is a Spark cluster. This is a data source which is continuously generating the data. My data will be flowing from data source to Spark cluster, which will be processed by Spark streaming, and output will be sent to live dashboard. Guys, my Spark streaming continuously running. We are getting the live stream of data from the data source. Look at it guys. And it is processed by Spark streaming in real time without any latency. The latency is merely at the level of second. And it is generating the output. Output data you can see in the orange colored box, and that data is going to the live dashboard. That data is going to the live dashboard. Now at this point of time guys, surely you will ask me, what is the application? What is the application or real life scenario for this? Let's take a specific example. Suppose guys, you are a network operator, a telecom operator. You are having your telecom network established across the globe, or let's talk about across the country. Now at any point of time, if there is any issue in your network in a specific location, say in Mumbai, in a specific region, in a specific cell, there is network issue. How old system handle this, including your MapReduce as well? You will collect the data, keep collecting the data. At the end of the day, you will get the data in your repository. Okay, and you will run batch processing at end of the day. Once you are processing in the night, usually you do your batch processing. Once you process the data, generate the insights, then you will generate final reports, and after reviewing those reports, your management will come to know, oh, there was a issue in a specific location, in a specific region, a specific cell. then they will take the necessary action. But isn't it too late? In today's industry, guys, customer is the king. If customer is not satisfied, if customer is not happy with you, immediately he will leave you. There are lots of competitors, alternatives are available. So guys, how Spark handles this? In a specific location, in a specific cluster, in a specific region, there is some issue in the network. In the live streams, in the real time, you will get the data. In the real time, you will get the data, and not only you will get the data in real time, Spark will process the data in real time. Spark will process the data in real time, and it will generate the insights, it will generate the reports immediately. Say for example, 5 seconds ago your network is down in a specific region. You are having reports ready, you are having insights ready, you can take the necessary action, you can inform concerned department, they will attend this particular issue. Guys, what was happening in old systems, old way, let's talk about that as well. Once you collect the data, you will store the data. After collecting the data, firstly you have to store the data before processing. I'm explaining, guys, the pain point that industry were facing, the issues that industry were facing, and how Spark resolved that. Guys, how latency was added. Suppose you are storing your data in any of the data store, whether that is Oracle, any RDBMS, or any old distributed system like SAN, or a latest distributed component storage like HDFS. In any of the system, in any of the storage system, if you store the data, what I'm trying to explain, if you write the data to the storage, the data will be parsed, the data will be converted into native form, the data will be serialized, the data will be normalized, the data will be indexed. Some of the operations are available in some, like 2 operations in Oracle, few operations in HDFS, and so on. So I'm giving you list of all the operations, and then it will be written onto the disk. Guys, this is adding huge latency in your processing cycle. First is the write data write latency. Now there will be another latency added, that would be data read latency. Before your processing system can process, he will read the data from your data store. Unnecessary 2 latencies, that too very big we are adding. That's why, guys, your storage then processing systems are not considered as streaming systems, is not considered as real-time analytics systems. Real-time analytics process the live stream of data, in real time, like how Spark streaming is processing. Guys, without storing, it is keep continuously accepting the data, process it, and write the data output to the live dashboard or to the data store. I hope, guys, Spark streaming, it's clear the need of streaming and the end-to-end processing, end-to-end execution. Let's talk about streaming in a little more details. Guys, it processes the data in real time, which helps the business to take the decisions in real time. Again, guys, similar point what we discussed with Spark SQL, it integrates very well with Spark's batch and interactive processing. Guys, in real time, when you work on the real application, there you'll find requirement that while processing any stream, you will need some sort of data from existing data store as well. Like some sort of masters are available, master data is available in your RDBMS or in NoSQL databases. You need mapping for that. How can you really integrate two types of processing in a single application? Spark provides such a nice feature. Guys, it processes streams of data on hundreds of nodes parallelly distributedly. That's why it achieves second scale latency. Spark streaming is called a near real-time analytics because it is second scale latency. Guys, at this point of time you should ask a question. Now already we had a pretty well established storm available, very well used in the industry. What is the need to replace storm? Guys, storm is not developer friendly. If any of you have worked on a storm, it is much too complex to code. Even for your small word count, you will be needing days to understand that. And to code complex applications, it's much too complex. That's why, guys, the one of the main reason for the replacement of storm is complexity. Apart from that, we'll compare different systems like Trident, like Storm and Spark streaming as well in dedicated session. So guys, it absorbs live data streams from Kafka, Flume, ZeroMQ, Twitter, etc. Out of which, if I highlight the most used data source is Kafka. Kafka, guys, if you have heard, this is the storage messaging queue, distributed messaging queue, Kafka. Kafka, guys, if I explain it in little details, guys, in all your big data applications, you always need a messaging queue which can buffer your data. If in case your end data store is slow, or for your streaming, you always need to buffer your data. So guys, earlier we had options like ActiveMQ, RabbitMQ, or memory databases like MemSQL, Redis. But Kafka is 1,000 times more rich than other systems. Guys, if I talk from the perspective of big data, there is no competition for Kafka. Because first important point, it is distributed. It is highly reliable, which provides supports replications as well. And guys, where your RabbitMQ is limited to just 20,000 requests, 20,000 records, 20,000 events per second, your in-memory database is also limited to 45,000 records per second. I'm talking about single machine handling. Kafka can handle 2 lakhs events per second. Other systems max limit was 45,000. Kafka, single system, single broker, 2 lakhs events per second. So guys, by the way, you should make a note, none of the big data application is complete today without Kafka. I have worked on more than 40 big data projects. I'm talking about end-to-end real life projects. None of them is complete without Kafka. Apart from that, another data collection tool which is pretty much popular part of Hadoop ecosystem, Flume. It can collect the data live streams from Flume as well, or to read the data, old data available in HDFS, or from ZeroMQ, from Twitter. Twitter is also providing data in Twitter streams. So guys, it absorbs the live data, processes it in real time, and write the output to HDFS or databases or dashboards. Usually For real-time analytics, we send at least one output stream to dashboards for live real-time dashboards. Let's proceed ahead. Let's talk about Spark SQL. Spark SQL allows relational queries expressed in SQL or HQL to be executed using Spark. It allows users to mix SQL and imperative or functional programmings together. If the operation is complex, can't handle with SQL, write functional programming there and mix it with the SQL. Again, important feature. Mixing is always important, critical. It is an engine for Hive data that enables unmodified Hive queries. No need to modify your existing deployments, existing Hive queries, existing data, and runs up to 100 times faster on existing deployments. It provides powerful integration with rest of the Spark ecosystem, that is integrating SQL query processing with machine learnings. The core of Spark SQL is schema RDD. Guys, as I told you, RDD is the basic level of abstraction in the Spark. How Spark supports SQL based on schema RDD, a different type of RDD that has an associated schema. Important point. Let's proceed ahead. Now guys, you will be amazed to see word count example in Scala. It's merely one line of code. As first line is just for reading the data from HDFS and last line is just to write the data to HDFS. This is the line, the second line, that is the code that is doing all the magic. That's it guys. This line I should highlight with star. That's it. For your complete MapReduce on cluster at the massive scale, what I'm doing, file.flatmap, that is transformation. Then guys, what we are doing, we are splitting the line with the space. After that guys, again we are mapping it, word and one, each and every word with one, word one, data flare one, technology one, training one, and reduce by key. Just reduce by key. All the code is available, rich set of operators, no need of any hand coding. You will be getting the required output. Guys, again at this point of time, recall Hadoop MapReduce word count example, more than 150 lines of codes, and here just one line. Similarly guys, word count example in Python, merely 3 lines. Let's proceed ahead. Let's talk about use cases. Guys, there are, by the way, tons of use cases. What was handled by Hadoop as well, what was handled by Storm as well. Let's talk about few of them in little more details. Network fault analysis. We already talked about it in great details. Real-time advertising analysis. Guys, I would like to take the example of Google. There are billions of users using the Google. Google is able to identify each and every user, and it displays the ad, it shows the ad that is highly content driven. For me the advertisement is different, for you the advertisement is different based on your liking and disliking. If I am searching for a mobile phone, Google will show me the advertisement of mobile phone. Real-time ad matching. It's not like that Google will be needing say 10 minutes or 1 hour time to for the ad matching. No, within real time, within sub-second range, it will give you the output. And after that, how your advertisements are performing. Advertisement analysis, predictive analysis, which is still a hot cake, guys. Predict the future using the machine learning algorithms. Predict the future, what will happen down the line, next 6 months, what will happen down the line, next 1 year, what will happen. Take the example of retail store. What will be my sales? What will be my sales of specific products in next 6 months or on the next festive season, next Diwali? Customer churn analysis. Customer churn, the biggest problem of customer facing industry. Everybody is worried, too much worried about customer churns. Guys, to find out the actual root cause of customer churn, just the customer complaints are not the sufficient data. You have to collect the data from consumer forum sites. You have to collect the data from social media sites, and you have to develop the logic, pretty complex logic, to generate the insights why people are leaving you. Everybody is, whether this is a telecom operator or a retailer, in all the domains, whether that is healthcare or a banking, financial domain, everybody is pretty much concerned about customer churn. Credit card fraud detection. Guys, this is one of the popular use case. To do a transaction, any of the financial transaction, whether that is your stock market transaction or credit card transaction, it will need hardly 2 seconds. During that time, guys, firstly you will authenticate the user, then check for potential frauds. So guys, classical example, if I give you, at 9 a.m. I am using the credit card from Mumbai, and just after 2 minutes from the same credit card I get a request from Chennai. The second transaction must be stopped. Apart from that, weather forecasting, healthcare analysis, they are, guys, by the way, quite nice applications are getting developed for healthcare analysis. One of my friend is recently has released one application that will predict which therapy should be used for the specific cancer patient. Like, you will give input as the your report of the cancer diagnosis, and algorithm will predict automatically that this particular therapy should be given to the patient. Apart from that, financial risk estimations and so on. There are tons of applications. Let's proceed ahead. Now guys, if I talk about job trends, job trend in Hadoop, the blue line represents Hadoop, that is a constantly increasing, the jobs are continuously increasing, and it is continuously going up and up and up. But the orange line, that is for Spark, which is not even exponentially, it is almost vertically up. That is not just for Spark, guys, concentrate here. It is Spark plus Hadoop. Alone Spark can't do much things. So guys, the companies that are using Spark, I have just highlighted big names here like Yahoo, Groupon, Amazon, UC Berkeley, Alibaba, Nokia, Taboola, Intel, NASA, IBM, Conviva, and so on. Lots of organizations are using it, and now people are moving to the second generation big data tool, that is Spark. By the way, guys, Hadoop is considered as the first generation big data tool, and Spark is the second generation big data solution.